Okay, good day, class. As I have seen our team, we are almost complete. But let's wait a few minutes for the others. So while waiting, let me ask if am I audible? Okay, thank you for responding. What about my presentation? Can you see now my presentation? Thank you. Since we are now all here, let's move on to our guidelines for the entire meeting. First, if you have some question, just tap the raise hand button of your team and open your camera as well as your mic to be recognized. Afterwards, I will call your name and you can ask it out. Okay, for the second guideline, if I am not audible, please do not hesitate to tell me or message me on Messenger so that I can work on that. Lastly, if you have no internet connection right at this moment, do not worry because this meeting will be recorded and you can watch it on your free time. So, welcome to your fourth quarter in Mathematics 10. Once again, I am your teacher in Mathematics. I am Maria Janet Gonzalez. You can call me Teacher Jack. So before we start formally our discussion proper, I know that everyone is wondering what will be our topic for the entire fourth quarter. So I prepared an icebreaker that could help you to guess what will be our topic. So we have here two sets of jumbled letters, and these letters have a hidden word. So your task is to guess each hidden word, and I will give you a prize, which is the load. Okay, let's start. So for the first word, who would like to answer? Okay, let's have Hardy. So okay, so you've said that the first word is position. Let's check that later. What about the second word? Okay, let's have Nika since you are raising your hand. So you've said that the second word is measure. So let's see. So what a great job! You two are correct. So we have the words position and measure. But what comes first to your mind when you hear the word measure? So let's have Mr. Radovan. Since you were raising your hand, what first comes to your mind when you hear the word measure? Okay, thank you. Well said. What about the second word? Let's have Joy Joy. Okay, thank you, Joy Joy. That's great also. So, let me define what measure is. So, measure is defined as finding out the length or capacity of something using a rule or standard or to compare or to judge. One more thing is that measure can tell us whether a value is about the average or whether it is unusually high or low. So for the position is the space occupied by an object with respect to another object. But when we combine it together, we will have measures of position. So who wants to read what measures of position is? Okay, let's have Miss Padilla. Okay, thank you. So I'm gonna read it again. Measure of position give us a way to see where a certain data point or value falls in a sample or distribution. We will discuss that later. And it is also can show how to values from different distributions or measurement scales compare. Look the pictures shown in my presentation. Do you recognize them? Okay, thank you for responding. Did you take the National Career Assessment Examination or NCAI when you were in grade 9? If so, what's your score? Okay, we have magtotal. So you know your score, but did you know your rank? Okay, thank you. But do you know that your rank was determined by using measures of position? Yes, we're going to discuss that deeper as we go into our discussion. So, have you thought of comparing your academic performance with that of your classmates? Measures of position have done that too. What about whenever your teacher asks your class to form a line according to your height? What is your position in relation to your classmate? Yes, that's the application of measures of position too. But have you ever asked yourself why a certain examinee in any national examinations gets higher rank than other examinees? Maybe right now, no, but as we go on in our discussion, you will be able to know it. So, in some colleges and universities, they are offering scholarship programs among graduating students who belong to the upper 5%, 10%, or even 25%. What does this mean to you? So with that, the measures of position takes place. They will be able to know what your position is if you are under the upper 5%, if you are under the upper 10%, or if you are under the 25%. By that, you will be able to know if you are qualified in that scholarship. And that's the great thing when it comes to measures of position. And I know for a fact that you take a lot deeper about measures of tendency, which are the mean, median, mode when you were in grade 7 and grade 8 or grade 9. I don't think so. I cannot remember. But for this quarter 4 in your grade 10, you will be able to know about the measures of position. And you are going to determine between the difference of tendency and position. But with this fourth quarter, our focus is about the measures of position. Am I clear? Okay, thank you for responding. So let's now move on to our lessons and coverage. So for lesson 1, we have the measures of position for ungrouped data. And for lesson 2, we have the measures of position for group data. As we go on to our discussion, you will be able to know the difference between ungrouped data and group data. As you can see in your screen, we have the module map for your fourth quarter. So we have first the measures of position, which is I've discussed a while back, and it has two kinds or two types. We have the ungrouped data and the group data. And under these two data, it has three, which are the quartile, decile, and percentile. And lastly, you will be able to solve real-life problems involving measures of position. Okay, thank you. So, we have now the measures of position. First, we have the quartile. When we say quartiles, it divides the data into four parts. The second one is the decile. When we say decile, it divides the data into 10. And lastly, the percentiles, which is the name for percent, and it divides the data into 100 parts. So, I'm warmly welcoming you to our lesson 1. Welcome to lesson 1, which is the measure of position for ungrouped data. So in this lesson, you will learn to illustrate the following measures of position, which is quartiles, deciles, and percentiles. And the second one is to calculate a specified measure of position. For example, 19th percentile of 30th percentile of asset data. When you will be able to interpret measures of position, and lastly, solve problems involving measures of position. But for today's topic, we will have quartiles for ungrouped data. So it means that for today, we're going to focus about quartiles for ungrouped data. So the quartile for ungrouped data, who would like to read? So let's have Miss Padilla. Okay, thank you, Miss Padilla. So when we say quartiles are the score points which divide the distribution into 4 parts, which have 25%, 50%, and 75%. So when we say 25%, this is below the first quartile. And when we say 50%, it is below the second quartile. And when we say 75%, these are below the third quartile. So it summarizes here the meaning of quartile. So we have the first quartile, second quartile, and third quartile. So when we say in the second quartile, it means that the median or the middle. So if we're going to have the quartile, first quartile, it is the median between the first data to median. And when we say third quartile, it means that the median of the second quartile to upper data or value. So we have the example number 1. So the owner of a coffee shop recorded the number of customers who came into his cafe each hour in a day. The results were 14, 10, 12, 19, 17, 5, 8, 9, 4, 10, and 11. So your task is to find the lower quartile and upper quartile of the data. For us to be able to find the lower quartile and the upper quartile, we need to transform first the given data into ascending order. So we have here 5, 8, 9, 9, 10, 10, 11, 12, 14, 14, and 17. So first, let's find out the least value. So our least value is equal to 5. And our median or the second quartile is equal to 10. And our greatest value is equal to 17. Please be reminded that for you to find the first quartile, you need the median of the least value and the second quartile. And in this data, the median of the least value, which is 5, and the second quartile, which is 10, is equal to what? Is equal to 9. Okay, very good. So we have here 9. So what about the upper quartile or the third quartile? So for you to find the third quartile, you need to find out the median between the second quartile and the greatest value. So here in our data, 10 is the second quartile and 17 is the greatest value. So what about the median of these two? So the median is what? Equal to 14. So that's it. Our first quartile or the lower quartile is equal to 9, and our upper quartile or third quartile is equal to 14. So I hope you got it. So let's summarize it. For you to find the lower quartile, it is the median between the least value and the second quartile. And for you to find the upper quartile or the third quartile, you need to find the median of the second quartile and the greatest value. So let's proceed to our next example. In this example, number 2, we need to find the average of the lower quartile and the upper quartile of the data. So these are the components and the quantity with the respective quantity. So first we have hard disk 290, monitors 370, keyboards 260, mouse 180, and lastly we have speakers, which is 430. So first we need to what? Okay, Mr. Magtoto? Okay, very good. So we need to transform the given data into what? Ascending order. So we have 180, 260, 290, 370, and 430. So what's the next step? Okay, let's have Mr. Bristol. Oh, you're right. So you've said that we need to find first the least value, which is 180, and of course the median, which is 290, and the greatest value, which is 430. So what's next? We have Nika. Okay, that's right. So for us to be able to find the first quartile, it is the median between. Okay, very good. It's the median between the second quartile and the least value. So we have what? 260. What about the third quartile or the upper quartile? We have Mr. Jomar. Yeah, that's right. You got it. For us to be able to find the third quartile or the upper quartile, we need what? The median and the greatest value, and the middle of these two will be the third quartile. So we have 370. But the question is, what is the average of the lower quartile and the upper quartile? So what are we going to do? Okay, we have now Miss Janet. Oh, we have the same name. So we need to add the two. Okay, very good. 260 plus 370. Okay. We have 260 plus 370. And what are we going to do? Divide it by 2 for us to be able to find the average. So what's the answer? Yes, that's right. So the average between the lower quartile and the upper quartile is equal to 315. So let's move on to our example number 3. So let me read the question. The lower quartile of a data set is the 8th data value. So the question is, how many data values are there in the data set? Okay, let's try this one. So this is the solution. Since we all know that the lower quartile is the median data of the lower half of the data set. So that means that there are 7 data values before and after the lower quartile. And so the number of data values in the lower quartile is equal to what? 7 plus 7 plus 1. So we have 15. And the number of values in the data set is equal to lower half plus upper half plus 1. So the number of the values in the lower and upper halves are equal. So the formula is what? 15 plus 15 plus 1 equals 31. So the data set contains 31 data values because, that's it. And don't worry, it's not so complicated because we have a shortcut for that. Because mathematics make it more easier. It doesn't want you to make simple things complicated. Okay. So this is another solution for example number 3. So we need to find the n. So we have 1/4 since it is a quartile, and n plus 1 is equal to 8. So we have what? 31. And we have another method. So this is Mendential and Sensage method. Have a look. And this is for upper quartile. And for the first one, it is 1/4 quartile. It is the lower quartile, and for this is the upper quartile. So let's proceed to example number 4. So we have the given 1, 3, 7, 7, 16, 21, 27, 30, 31, and which is the n is equals to 9. So let's use the method I've said a while back. So since the n is equals to 9, we have the first quartile as what? 2.5. What about the third quartile? So instead of using 1/4, we use 3/4 because since it is 75%. So the answer is 7.5. Now let's move on to another method which is called linear interpolation. So let's use it. This is the example number 5. Find the first quartile and the third quartile given that the scores of 10 students in the mathematics activity using linear interpolation. So this is the given. 1, 27, 16, 7, 31, 7, 30, 3, and 21. So this is the solution. What we should do? What we should do is to arrange the given score in what? In ascending order or increasing order. So we have now 1, 3, 7, 7, 16, 21, 27, 30, and 31. So first, let's locate the position of the score in the distribution. Since the scores are 10, or 9, so the n will be 9, and we will have the first quartile as 2.5 as seen in your screen. So in letter C, since the answer has decimal point which is 0.5, we need to interpolate the result. So in letter C, third, interpolate the value to obtain the first quartile. So what are we going to do is to subtract the second data from the third. So the second data is equals to 3, and the third data is equals to 7. So we have what? 4. And our step 2 is by getting the first step, you need to multiply it into the decimal point that we arrived last step, which is 0.5. So we have now 4 times 0.5 is equal to 2. And for the step 3, add the result in step 2. So we have now add the result into the step 2 to the second or smaller number. So we have now 3 plus 2, which is equal to 5. Therefore, the value of the first quartile is equal to 5. Let's try the another one. So first, again, we need to arrange the given data. So we have that. And, of course, in letter B, locate the position. Since we are now looking for the third quartile, we use 3/4. And, of course, the n is still 9. And we have what? 7.5. And still there is a point, so we need to interpolate it. First step is to subtract the 7th data from the 8th. Why 7th data? Okay, very good, because it is in the upper quartile. So what is the 7th data? It is 27 and the other one is 30. So we have 30 minus 27 is equal to 3. So multiply the result by the decimal part obtained in the second step. So we have 1.5 since 3 times 0.5 is equals to 1.5. So add the result in the step number 2, which is equal to 15, and add it to the second or smaller number. So we have now 27 plus 15, because we use 27 the step 1 and that's the smallest number. We have 28.5. So therefore, the value of third quartile is 28.5. Okay, you did it, guys. Okay, summing up, we have the 4 words here in your screen. Measures of position. Okay, let me call someone. Okay, Mr. Kaakbar. So what you've learned about measures of position? Okay, thank you. That's great. What about for quartiles? Let's have Mr. Harley. Okay, very good. And what about deciles? Miss Quintos? Yes, well said. What about for the percentiles? We have Miss Padilla. That's good also. And for the next one, we have the method we use. First, we have the Mendenhall and Sensich method. So, what we do in that method? Mr. Magdado? Okay, thank you, Mr. Magdado. What about for linear interpolation? We have Mr. Ranit. Yes, very good. You definitely summarized the method. I love it. So thank you. And since I know that you already understand how to get the quartiles for ungrouped data, this is your test. The activity number 7. So it is entitled as How Old Are You? So Albert is the main character. It has an assignment to ask at random 10 students in their school about giving their ages. So the data are given in the table below. So this is what are you going to do? What is the quarter 1, quartile 2, quarter 3 of their ages, and how many students belong to quarter 1, quarter 2, and quarter 3 in terms of their ages? And third, have you realized the process of finding quartiles while doing the activity? Yes, I think definitely it is yes, but you need to answer it. So this is again your task is to watch this link. I'm going to send it on RJC, and yeah. Okay, again, thank you. I am your once again teacher, Maria Janet Gonzalez, and hoping you have a great day with me. And these are my references. Okay, good day. Thank you. Goodbye. And I'm going to download your attendance. Thank you.